So in this video, we're going to go over some of the questions that usually come up on this chapter during the homework. So let's go look at homework number 30. So we're going to do 38, 44, 46, and 68 today. So let's do 38 first. 38, capture the flag. Two opposing players in capture the flag are 100 feet apart. On a signal they run, capture the flag, and you have x1 and x2. x1 is given as 10 t minus 0.1, where x2 is 100 and minus 9t. 100 minus 9t. So if you look at it, you have 0 here. You have x1 who is right here, and you have at 100 feet you have x2, and they're both trying to capture the flag that's in the middle at 50. Okay? So as you can see, x1 is 10t minus 1. So in other words, it would be just normally 10t, but he hesitated for 0.1 seconds. All right? And so he's going in this direction, as you can see, he's going this way, whereas x2 is going this way. Started at 100. When t is equal to 0, I'm at 100. But he's going in this direction, negative 9, so he's going at a speed of 9, where this guy's going at a speed of 10. So this guy's going faster, but he got a later start, right? Okay? So that's what's going on here. And who captures the flag and by how many feet? Obviously, A is, you can do it on your calculator and find out. In B, we'll do this algebraically. So who calculates, who gets this further? So if I set this equal to 50, and this guy equal to 50, let's calculate the time. What do I get here? I divide this by 10, so I'm going to get 10. T minus 0.1 is that, so I'm going to move the 0.1 over. So T is equal to 5.1. That's 5 plus 0.1. Over here, if I move this guy over, I get negative 50. Negative 9t is equal to negative 50. T is equal to 50 divided by 9, which is going to be what? I'm going to get 5.5555, right? So this guy gets there in 5.1 seconds, where this guy gets there in 5.55 seconds. So obviously, x1 is going to get there quicker at 5.1 seconds. The question is, catch a flag and by how many feet? So when this guy is at 50, we need to find out where this guy is. And you would plug in 5.1 into here, and you would get 100 minus 9.9 times 5.1, which is going to be, this is x2, this guy's x2. You're going to get what? This is 100 minus 45.9. So this is going to be 54.1. So this guy's going to be 4.1 away. So x1 is going to capture the flag before x2 by 4.1 feet. Okay? So that was 38. Now let's move on to 44. Hitting a baseball. Kirby hits a ball when it is 4 feet above the ground with initial velocity of 120 feet per second. Leaves the bat at a 30-degree angle with the horizontal, heads towards a 30-foot fence at 350. So does the ball clear the fence? So let's go. This is pretty similar to example number 9. Right? So 44. 120 feet per second at 30-degree angle And we are how far off the ground? We are 4 feet above the ground. Okay? So, in the x direction, I have what? 100, this guy, right? So I'm going in the x direction, so it's 120 cosine 30 degrees t. Y is equal to negative 16t squared plus v naught, which would be this guy. So it'll be 120 sine 30 degrees t plus 4 feet above the ground. Was it 4 feet above the ground? 4 feet above the ground. Okay. Does it clear the fence? The fence is at 30 foot high at 350 feet. So 350 feet. So we traveled 350 feet. So I went like this. And I traveled, I don't know where it's going to be, 350 feet. So in the x direction, I went 350 feet. In the x direction, 350 feet. 120 cosine 30 degrees t. T would be equal to 350 divided by 120 cosine 30. Cosine 30 was root 3. Root 3 over 2. So I'm going to get 350, 120, root 3 over 2. 360. I wish it was 360. 350. I'm going to get 60 root 3. Okay? And you find that time, and you'll put that time into here. Okay? If you find the time, 44, the time's going to be equal to 3.37. So this is going to be equal to 3.37. You put that guy into here, you're going to get what? If you put that into there, you get 24.59 feet. 24.59 feet. T, feet. Okay, so the question is, so did it clear the 30-foot fence? Obviously it didn't, right? Because it's only went 24.59, right? So it did not clear the 30-foot fence. And then B, if so, by how much does it, no, never clear the fence. If not, could the ball be caught? Can the ball be caught? Can you catch a ball that is 24.6 feet high? The answer is no, you can't, right? So the answer is no, again. All right, so that's 44. Now let's go to 46. So we have 44. We go to 46. We have two softball players that are throwing a ball at each other. And you want to find out the question about the distance between the two balls. So we have Chris and Linda warming up. Linda, they're both 5 foot off the ground, which is nice. So they launch at the same height. So we're going to have what? We're going to have 45 at 44 degree angle. So we have a 45 at a 44 degree angle, and over here we have a 41 at 39. 41 at 39 degrees. So this question is really all in the setup. If you set it up correctly, you're going to be okay. So that's going to be the hard part here. Okay? So since they're both 5 foot off, we're just going to call this 0. We're going to call this point 0. Okay? So this is going to be 0 here, right? In other words, this is 0 height right here. Okay? So we're going to do 0 here. So in the x direction, I'm going to have what here? For this guy, I have x is equal to 45 times the cosine of 44 degrees t. Y is going to be equal to negative 16t squared plus 45 sine of 44 degrees t plus, we said it was at 0 because they're at the same 5 feet, right? So we're going to go ahead and call that 0. So that's it. So for this guy, we're going to have what? X is going to be equal to what? Since this is 39, it's going to go this way, so it's going to be 41 cosine 39 degrees t, but we are going negative. We're going in this direction, and how far apart are they? They are 78 feet apart. So this guy here is 78. So x is equal to 78 minus 41, because we're going this way, right? We're going this way in the x. Y is negative 16t squared plus 41 sine 39 degrees t, and there's no plus 5 over here. And the reason why this is plus where this is negative is because it's still going up this way. It's going up in the same direction, right? The y direction right here, right? So it's going up, right? That's why this guy is positive, whereas this guy over here was negative, okay? So this is the parametric for this guy. This is the parametric for this guy. So the distance, you're just using the distance formula, right? So the distance formula is what? x2 minus x1 squared plus y2 minus y1 squared, right? So you just plug and chug these guys in here, right? x2 over here. So you're going to get, this is going to be equal, I'm going to go ahead and write this over here. So this is going to be equal to the square root of x2, 78 minus 41 cosine 39 degrees t, so that's x2. Then we're going to subtract x1, subtract this guy, subtract 45 cosine 44 degrees t squared. Then you're going to go plus the y2 plus 41 sine 39t. And then from there, you're going to subtract this guy. So I'm going to subtract this guy, so this guy becomes positive, 16t squared, and I'm going to subtract minus 45 sine 44 degrees t quantity squared. Okay. The only thing interesting that happens here is that this guy kind of cancels out. So that's kind of the only thing that's really interesting here. But the rest, you would just go ahead and put this in your calculator, and you would graph the distance. You would graph the distance, all right, with t. So you can graph this, and you'll find out where it's minimum. Okay? And if you do that, you get your answer is 46. You do that, and you get 1.21 degrees. 1.21 seconds, and the distance is about 6.6. So when t is equal to 1.21, your distance is going to be 6.6. Okay? So you put this guy right in your calculator. Okay? Again, it's not this part that is hard, it is setting it up that is hard, okay? Things that you would kind of forget is this guy, all right? So because you're 78 away from here, and this guy here being negative because we're going in this direction, okay? You have to pay attention to that, all right? Okay, so that's 46. And last, we'll do 68. So 68, we have a Ferris wheel, throwing a ball at a Ferris wheel, a 71-foot radius Ferris wheel turns counterclockwise 1 revolution every 20 seconds. Tony stands at 0.90 degrees at the right of the 90 feet to the right of the base of the wheel. The instant Matthew is at 3 o'clock. Tony throws a ball. Blah, 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 blah. Okay, so the one thing here that they do not say that you have to assume is that you have to assume that the ball is being launched at the same height that the clearance of the Ferris wheel is. So in other words, you're going to have a Ferris wheel that is looking like this. Okay, so there is some height here, but that height is going to be offset by the ball tossing guy's height here. Okay, so you have to assume that. because they don't say that, right? So this here was 71 feet. And how far away was he? 90 feet to the right? You're 90 feet to the right. 90 feet to the right. And you are going this way. 100 degrees, I believe. 100 degrees. 100 degrees from the... There we go. And velocity of 88. One revolution every 20 seconds. So this is 88. 88, okay? And the other guy is sitting right here, okay? So it's one revolution every 20 seconds, so we have to find the B value for that, right? So the B value is going to be what? 2 pi divided by 20 seconds. You get what? Pi over 10. Pi over 10, so you're going to get what? So this guy is going to be what? For the cosine, the x1, x is going to be 71 cosine pi over 10t. Y is equal to 71 cosine pi over, not cosine, sine. Sine pi over 10t, and that would be if the origin was the center, but the center is not the origin. You have to add the 71 here, right? So you have to add the 71, okay, to bring it back up, right? So this is the parametric for the guys right here. Now the ball that's leaving from here is going to be what? You're going to have, in the x direction, you're going 90, from 90 you're going this way. So I need the x direction that way. So it's going to be cosine 100t. And then that's the x. The y is going to be equal to what? Y is going to be equal to negative 16t squared plus 88 sine 100t. And since it's at 0, there is no 0 here. Okay? So there you go. So again, you do the same thing here. You would do now, you're going to erase this, and we're going to do the distance. So the distance is going to be what? The distance, this guy, 71 cosine pi over 10t minus 90 cosine 100t squared. Then you're going to subtract from here. We're continuing. And then we're going to subtract. Then we're going to go plus this guy, 71 sine pi 10t plus 71. Right? This guy minus that. So it's going to be plus 16t squared, 88 sine 100t quantity squared. And again, you would go ahead and just graph this. And if you graph it, you'll find out that there is a minimum at t is equal to 2.19. T is equal to 2.19. Your d, the minimum distance, is going to be about 3.47 feet. 3.47 feet. Okay? So this is a combination because you combine the Ferris wheel with the ball throwing. Okay? Interesting question. All right? Okay? And that's it.